This is Lab 6, Off-Axis Aberrations. I'm Nathan Isham.
I'm Stephanie.
I'm Alan. So coma results when the magnification of the system varies with the pupil position. So you will get like a asymmetric cone shape blur at the image plane. So for tangential ray fan, it is linearly dependent on the field height and quadratically dependent on the pupil position. And it has no contribution to the sagittal ray fan. So the sagittal coma and the tangential coma are two other measures of coma.
So astigmatism is when the tangential and sagittal rays focus at different points, and this causes the points to focus, or the rays to focus at a line rather than points. And here is our equations for astigmatism with our h-squared dependence.
So for the setup, we construct the beam expander using the microscope objective with NA of 0.35 and a spatial filter of 25 microns. So in order to fill the 1-inch Harman mask, we calculated that the expansion ratio has to be 28.6 using the lens with a focal length of at least 229 millimeters. So we decided to go with a collimation lens with a focal length of 250 millimeters. So the mirror is placed at the end of the first rail on the rotation stage. So that allows you to align the beam onto the second rail. So we're using a mirror instead of the prism this time so that we can adjust the field angle for the off-axis aberration measurements. So the Harman mask was placed right in front of the test lens, which is a plano convex lens with a focal length of 100 millimeters. So the microscope is also placed on the X and Y translation stage. And since the mirror is moving along the first rail to adjust the field angle, so the axis perpendicular to the second rail will be considered as the y-axis, while the other one will be the x-axis. So to align the microscope on axis, we have all 5 holes on the Harman mask open, and then we adjust the microscope in the x and y direction until the 5 beams overlap onto the screen and create a mesh-like interference pattern.
For this lab, we had to measure coma and astigmatism. To do these, since they're off-field aberrations, we had to create a field that was coming in at an angle. To create this field, we had our microscope, which was aligned at origin, and adjusted it until it was off-axis. We then came back to our mirror and adjusted it along the z-axis and in rotation until we were able to get the grid-like pattern on our viewing screen again. Once we had an off-axis field that was centered on the cross, we could go ahead and start measuring coma and astigmatism. To get the tangential coma, we would block all 4 holes except for the left or right hole and see how far on the y-axis of the microscope we had to move it to recenter the dot. Then we did the same process to find sagittal coma, except we didn't block the top or bottom holes. Then, after we had found coma, we could go ahead and find astigmatism. Astigmatism was almost the same as coma, except you would leave either the horizontal or the vertical holes open to find the tangential or sagittal astigmatism. And we also had the z-axis free when we found astigmatism. So for astigmatism, we had to recenter the dot onto the crosshair like we did for coma, but we also had to make sure that the 2 dots overlapped by adjusting the z-axis.
So this is our tangential coma and sagittal coma for our 100 millimeter focal length lens. We notice a linear trend in this aberration due to its linearity of the field height. We see a decrease in coma with increasing field height. And we also have our horizontal and vertical astigmatism, which has an h-squared dependence, which this kind of shows. We weren't able to see as good of data as we would have hoped, and we kind of thought that this was due to an offset in our alignment, so some misalignment somewhere.